Hello, everyone. We are here for another Fireside chat. I'm Sandro Mancuso. As always, I'm here with my colleagues, Mashooq Badar, José Huerta. And today, we decided to kind of continue the conversation that started on the previous episode. In the previous episode, we were talking about quality in general. And there was also a suggestion from Cesar Augusto Zapata that asked us to talk about technical debt. And we felt that this would be a good topic and would be almost a continuation from what we discussed on quality. And it's also a very interesting topic that we always need to address in every project. So we would like to start this one. Maybe we try to, how do we define technical debt? Let's start there.
Okay, well, I can start. I think, first of all, it'll be good to harken back to the first time the word technical debt was mentioned in context of software, and that's Ward Cunningham in 1992. And he talked about first-time code as incurring debt, and that every time you make more changes to it, you pay interest on that debt, and unconsolidated debt can then halt the whole change process. So there were the three key words, like, first time code always is like debt, first time. And I think that's an interesting part. And then paying interest on that debt, and then not consolidating this debt can halt the change process. So there's a lot to unpack there, but I think it's important to kind of go back to that definition, and I think it's a very good definition indeed.
Jose, well, how do you feel about it?
Well, the thing is, you're talking about first time. Let's start with that definition. No, you're talking about first time code, and you could argue, that the minute that you write it, it's already kind of legacy. It already started, accumulating that debt. No, and the question that I would ask, and I think it's quite important, is how did we get here, right? Because a lot of the times, when you just wrote the code, that's a very small amount of technical debt that you need to pay if there is almost anything, no. But if with time it just accumulates, right? It starts getting that compound interest, and then it becomes a problem, right? So I guess that it is as important, how to manage it as it is understanding where it's coming from, and how to, if you can, avoid it, which is another question mark, I guess.
So like before we even go into the how we got there, because I think that this is quite an interesting angle for us to tackle as well. So how do we accumulate that debt? I want to just to add a few things to the definition itself. So I like the that we have a term that we can use and we kind of know what we're talking about. The definition itself, I'm not sure if I agree 100% with the original definition, but I like to have a simple way, or a word, or a couple of words in this case, to refer to something. But because I was thinking, as you were saying, Matt, what if we don't need to pay that back? See what I'm saying? Or how much do we need to pay? So I like the metaphor, I like the idea, but if you really think about when we try to categorize, it's almost like legacy code. It's almost the same thing for me, because like they are quite tightly related. But like, if let's say that given whichever quality standards that the team might have at some point in time, let's say that there is a piece of code, regardless of when it was written, maybe yesterday, maybe 6 years ago, and let's say that this code is below the threshold. But let's say that this code is not in the way. Is it technical debt?
No. I mean, this is why I really like, maybe it's not really a definition, it's how, Ward Cunningham used it almost like a metaphor, right? Mm-hmm. But, he said, like, first of all, is the first time code part, right? It's saying that, almost taking it down to the red green refactor of TDD. That is almost the red green, and we haven't done the refactor. So we haven't. We've done it. It works, but we haven't made it better or let's say simpler. That's also a big
Your
topic
first
in it.
draft, no, so
Yeah,
to
your
speak.
first draft. Basically, we've taken the first draft and we said that'll do, right? But then he says that I can't remember exactly but every time you change it, I guess, I think that you pay interest on it. So it's more about you pay interest when you change it. When you are working on it again, you pay interest because debt is associated with it, right?
Mm-hmm.
And then he talks about unconsolidated debt. So if you keep doing this thing over and over again with code that you have to change, I think that is part of it. Is that then it becomes, there is more and more of this stuff that is actually debt that is more and more difficult to change, and you're accruing more and more interest on it. And when it's not unconsolidated, you can grind to a halt. So it talks about how it starts to happen. When you start changing it, you are paying the price, and you keep paying the price. And it's not just that you are paying that price, it's kind of almost getting bigger and bigger to the point where it will grind to a halt. But I think it's all in the context of you are changing that stuff. It's not as you said, if you create a draft, it goes out, it's doing what it does, and you never have to touch it, you're not going to pay that debt ever. Right?
I see. So there is also a degree of I'm trying to be the devil's advocate here, right? So just trying to expand on the. I never thought very deeply about that because you get the concept and you move on with it. But so there is a degree of a gumbo as well, or kind of a measuring your investment, or in a way. Like, for example, okay, I might be able to. I'm not sure if I'll need to pay this back, or it's not that clear, and I'll take a gumbo. Is that is there something in there?
Yeah, I mean, I guess so. Sorry, so Jose, you were gonna say something.
No, it's along those lines. For me, this is very much related to the economics of holding. No, that idea of having a cost of holding something, no, and having a cost of the transaction, right? And the example I always use for this thing is, imagine that you want to have breakfast with an omelet, right? You could go to the shop and get one egg. That's your transaction, no, like going to the shop and do your omelet and do that every day. Yeah, of course, we all know that it's better, if you go to the shop and buy a dozen of eggs, no, and then you have one every day. You don't have to, but you don't go to a shop and get 100 cards of eggs. So there is a cost to keeping that 100 egg in your fridge. No, there is a cost to going to the shop and paying that transaction. And it's the same for Tenniel, that you can accumulate some of it, no, and you're okay with that. When it starts becoming something that you cannot handle, or it's slowing you down, or taking you to a halt, then you need to have that balance between how much you're paying and how much you're accumulating, right? And economically, that's actually described with two different curves, and it creates kind of like a parable, right, with a very flat bottom. So it doesn't really matter what the optimal point is, as long as you are within certain range. No, you're not accumulating too much, and at the same time you're not like constantly paying that debt. No, you're kind of okay. You're kind of in the zone of that equilibrium, no, that you're trying to. But in order to do that, you can't wait until it's impossible to change things to say, oh, this is too much. No, and I feel like it goes to your question, no, Sandro, to your point of how much of that, no, or how do you quantify it? Is it even, if I'm not going to use it, is it even something that I should be quantifying and thinking that I need to repay it? No. So yeah, it's interesting, because I don't have an answer to that. Like, for me, if you're not touching it right now, it doesn't have a direct impact. But what if when you want to touch it, it has a huge impact, right?
So in a way, as Sandro said, it could be like a gamble as well, right? Because you may never touch something, and I think in the modern day practices, like things like microservices and so on, you have more of a chance of that. But actually, when you're talking about unstructured monoliths, especially, even if you don't touch that piece of code, it's entangled with, or that functionality is never changing. It's entangled with all other sorts of other things that you are changing. So it is getting in the way whether you are changing it or not, right? So it's still accruing interest. Whereas actually going to a more modular or microservices type approach, where you're saying, actually, I might create disposable code that I'm just going to put out there. I'm not going to change it because I don't think it needs to be changed, but I am actually ensuring that gamble, or kind of ensuring against it by saying that if ever I have to, I'm just going to throw it away, and I'm gonna make something a bit more.
But is it ensuring a gamble, or is it like reducing the cost of paying that transaction, no? Or getting rid of that debt, no? Because what you're kind of describing for me sounds like I'm going to isolate that, no, in a way, or I'm going to make it small enough that it's easier for me to just throw it out the window and redo the thing. That has a lower cost, no?
Yeah.
Than
Well,
actually going and trying to change it.
Well, the insurance as an instrument is that it's about lowering the risk with lower cost than to actually, build the strongest thing that will never fail in your context, right?
So basically, like, according to what you're saying, like, I'm just trying to distill some of the things you said. One way to manage technical debt, and not the technical debt itself, but the risk, like, as you are incurring the debt, you can have actions to manage the risk. And one of them, from the examples you gave, is kind of modularization in a way, right? Mm-hmm. If you go all the way to separate services or microservices, if you go all the way, or if you just keep like more well-defined modules, because what you are doing is, like, you can have like modules that are a bit messy in a way, but if that separation is very clear and you manage to create a good separation of concerns, or even like domain functions or bounded context, if you like the domain-driven design naming, is so this separation of concerns is a way also to localize change. And then each one of those modules, you can operate at different levels of quality. And if you ever need to repay the debt, so that means change one of those modules, it's a bit more localized, right? So is that what we were?
Yeah.
This is one way of managing that.
Yeah, and you're paying less interest because it's not getting in the way. It's not entangled in other things. So even when you don't have to change it, like with the unstructured monolith, it's in the way. So you're still paying interest on it. Whereas if it's on the side, you're never even looking at it when you're changing other things. It's even better, and that's where modularization pays on the other end as well, which is to kind of reduce that cognitive load, as it were, of what you're working with.
And it's funny because I have some concrete examples where the code being entangled, although you're not changing that code, but it gets on the way. So we were trying to redesign a specific flow of one of our applications in one of our clients. But the problem is that the flow, there were multiple, business-wise, there were multiple flows. Code-wise, there is a blob. Mm-hmm. So in order to stabilize one specific flow that's the one that we were interested in, it was very difficult because, like, we didn't know if we just tried to rearrange or restructure that flow. And that was a combination of re-architecture and redesign. So we had to change a few systems and also the monolith. But we had no clue if we would be breaking something else. So it was code that we didn't need to change, but because it was intertwined, it didn't allow us to isolate the change that we had to make. And for the testing, the same thing. We wanted to have tests at a higher level. Well, it should be fair at all levels, even at a smaller level. It was always difficult to test because we had to involve within the scope of the test pieces of code that didn't belong to the thing that we wanted to test, but they resided in the same classes and methods and stuff. And that was an example of what you were just saying, Mash.
Yeah.
I would add to that, like that's a good example of how even your delivery is part of that right? Like if you're able to put things into production, to do things like continuous delivery, if you have your quality gauge set up right, and you're able to make those changes and sort of like reduce that transaction cost that we're talking about, no? Because you don't have to either do a big investment in changing a lot of things and then doing the release. That's of course, you're accumulating more of that, no? The risk, it gets bigger, right? And at the same time, it allows you to finely tune what it is that you want to do. And again, going back to you move back a couple of years, or well, some clients still do similar things now, but you would have to burn your software into a CD or a DVD and ship it somewhere, right? So doing a new release, right, would be very costly, right? But today that's not the case. You can actually reduce that and make it cost nothing, and then you can start having that flexibility of deciding when and and where and how much you want to do. So for me, it doesn't just include the code, but the practices that you have around actually building that software are also part of that technical debt, if you will.
So this leads you to like one of the questions that you were asking at the beginning, like is how we accumulate that.
How did we get here in the first
place? Exactly. How do we get there? And actually, like as you guys were speaking, like when we were trying to go back to the original definition and stuff, normally when we talk about technical debt, we talk about almost a trade-off. So like, we're gonna maybe incur some technical debt because we want to release faster, or there is a deadline and things like that. But as I was thinking about it, because we say like, if you are gambling, which means that you know the consequences of what you are doing, and you are measuring the risk, but you know the consequences. You know that consciously you are incurring technical debt, and that led me to think like, are there different types of technical debt? For example, the ones that you incur consciously, and that implies a trade-off, that is something that is of more value or more importance that you prefer to do. But there are also the unconscious one. And I believe that is a combination of both conscious and unconscious technical debt. And unconscious, like, is basically you are doing things without having other skills. So you are trying to do a good job, but sometimes the teams don't have the skills to do that job. And so those are... Yes.
Sorry. I'd actually like to add, there is a subsection of this unconscious technical debt, which is technical debt introduced purely because you are trying to avoid technical debt. So this is this often happens, and I've seen it a lot in kind of mid towards high skilled teams.
Where over-engineering.
Where there is a lot of over-engineering purely to avoid technical debt, and ironically is the thing that is causing it.
Okay, that's a very interesting thing. So let's
you can go also, Mash, into accidental complexity. I know you like this this subject as well, so please be my guest.
Oh, where do I start? Okay, I don't know if you want me to go into accidental complexity.
Yeah, why not? Because I think that's also kind of a factor that is that creates.
Okay, so I mean the way I describe it is at least it's about complexity at two levels, right? There's a complexity in the problem, and then the complexity in the solution. So your solution will obviously have to be as complex as the problem. but that's very rarely the case. We make it way more complicated than the actual problem. And normally that then relates to the over engineering. So I always, when I talk to people about, design, software design, and say, well, okay, this looks like really complicated. Yes, it's very complicated, but is it complicated because you've kind of trying to think about how the system is going to change, and you're trying to add all these different types of abstractions and different types of design patterns and architectural patterns and all those kind of things? And even I've seen testing that is actually, it's meant to make the change easier, but is making the change much, much more difficult. In fact, there was quite a famous article that talks about pouring concrete all over your code. You're writing tests as if you're pouring concrete all over your code. So it's super, super difficult to change. And all these things I call accidental complexity. I mean, of course, you can give it many different names, but they are not related to the problem that you're trying to solve. They're relating to the solution, the way you've designed it, and going kind of the skill to actually create a solution that is enough for now and is actually small enough that you can even in some ways just throw it away and do something again, rather than to have this complex thing that thinks of all the different eventualities and tries to cater for them. And actually you end up really being quite rigid and making the code base so difficult to change, and effectively adding a lot of technical debt.
You know that there was a time I was thinking about those things, where I was thinking about over-engineering, and that normally we associate today as a bad thing. But there is something to say about under-engineering as well. And normally, like the code bases that we normally say this is over-engineered. Let me give an example to probably be easier to make my point. Take a monolith, for example. A monolith, because we try to clump so much behavior in it, in one single place, so many flows and stuff like that, we end up trying to create those protections of the flows and the modules inside the monolith. So we tend to over-engineer. So most of the monoliths internally, they are over-engineered to try to create those protections. So they are over-engineered in the small. But in the large, which is an architectural side, they are completely under-engineered because they just have one system. So for me, there is something to be said of where you over-engineer and when you under-engineering at the architecture level sometimes causes more problem than over-engineering on the small level.
Mm-hmm. Totally, I think it's a very good point. The reverse is true as well. Like people used to quite recently, when the microservices kind of fad was on its zenith, that we have 5,000 microservices, come work for us, and that is kind of over engineering on the
Architecture on the big, but there is a tipping point, right?
Yeah, it's a balance. Yeah. It's a balance that you need to achieve. Like pulling one lever can make the other one better, exactly. But how far do you pull it that you're causing more problems than you solve? Right.
Yeah, the extremes are always bad, but I think that it's fascinating. Sometimes, in order to solve an over-engineered system at the small, you need to resolve the under-engineering that we have in architecture. That means engineer your architecture. So evolve your architecture in ways that you can pull the pieces out of that monolith and separate them better. So you will start engineering better at architecture level and lowering and under-engineering at the small level, keeping the small level simpler. And try to reach
I think there's also, I mean, it's like everything. There is also a risk in that. No, I feel like the driver for it should be the actual change that that the product needs to undergo, or the system needs to undergo, and you should be, doing the easy change and making the change easier as well, right? So as you're getting those requests, or as your system is getting this, pools, no, to change and adapt, then you need to go and look at the bigger picture, not just look at the micro and how to solve, but look at the bigger picture. But starting either way, like either over engineering at the micro and at the macro, I still feel like that's like this is especially if you're working with startups or that kind of stuff, right? Like you want an MVP, right? You want to push things out and so on. But if you're making it already thinking that it needs to scale to this many users and so on, but you don't have the current number of users is 0, right? So I feel like there's also that part there, right? Like they start with what is it that we need to get, and then from there you can always look forward, you can always do a bit more, but not start with a preconceived idea of where we're going to be in like 5 years or whatever, right? And go from there.
Yeah, but that also relates
that's
to
just my
no, it totally makes sense. But for example, the things that you are mentioning, they imply a conscious decision, right? So for you to understand those trade-offs of where where you're going to incur debt, how much debt you're going to incur, and also try to analyze the risk of how much if you need to pay interest on that debt, what is the risk? How much interest would I be paying, or are we willing to pay? But all of those those questions, they imply conscious decisions. But I argue the technical debt that is accumulated unconsciously, right, by lack of skills. So when I look at the monoliths, sometimes you see, for example, when you have like signs of over-engineering inside the monolith, or even over-engineering on the architecture, you can see that someone at least was trying. They say, you know what, this might change, so I'm going to create a few layers of protection. So they were trying to protect themselves for a potential problem that they would have. So they made a conscious decision to do that. Maybe it was a bad decision, but it was a conscious decision to create those things. They might lack in skills, and they made that decision too prematurely or without the right skills. But quite often, most monoliths that you see in there, you don't even see the attempt. It's just a blob. It's just like a bunch of code hacked together, patched together, but there was no resemblance of, even if it was bad, but there's no resemblance of an architecture. Even if it was a bad one, I said, at least they are trying.
Yeah.
But I think that there is something to be said about how we get there, and I believe that big chunk of it is part of education and at all levels in skills.
Yeah, it's definitely the actual order of make change easy and then make the easy change. That's very important, right? It's not about make the change easy or make the easy change and then make change easy. It's the other way around, right? And there are two aspects to this skill, and this goes all the way back to TDD, at the lower level, which is red, green, refactor. Yeah. Now the way I see it is that there is a skill related to effectiveness, which is making the easy change, and there is a skill related to a good understanding of software design that is making the change easy, right? And I think you get this problem at the very start of, like, we have some clients who have thousands of developers, and they are hiring developers and not necessarily training them sometimes well enough. They understand they understand how to build a feature, but they don't understand how to design software well. So what they do is, this new feature is coming in. Oh, it's kind of a variation on this thing. I'm going to add an if statement there, but it's actually different fundamentally. So I'm going to have to add an if statement there, an if statement on that side and over there. What they don't understand is that change is not localized. This is not cohesive. and then you then have this kind of coupling going on, which is one of the worst types, which is like knowledge, right? The same knowledge exists in many places. You can call it duplication as well, or duplication of knowledge, right? And they don't understand that, or the problems with that, and they will just start adding these things. So that's one aspect, which is totally, and in some other situations, you see this is the biggest problem. It's just one if statement on top of the next, and the whole system. And this is why you see methods that are thousands of lines long, and classes and so on, right?
So maybe like if we are saying that skills are an important aspect, like for example, is or lack of skills. And those are not just like at the coding level. That is also at an architecture level. Is the way that you come up with backlogs, and we organize how well you know the domain that you are working on, and how the business domain maps to the systems that you have, so that you know where to make the change and stuff. So part of managing, so that led me to think that part of managing technical debt, but in a strategic way, not, for example, a technical debt you already have, but if you are managing a system or a project or a department and stuff, you need, I'm thinking that it's almost impossible to prevent technical debt to emerge, right? Mainly the unconscious one, right? So, but you can potentially try to manage that better, having a more proactive management of that debt, investing on education. And education is not only about the low level, the TDD, because the easiest one that we normally come up with, okay, maybe they need to learn more about TDD and clean code. Yeah, so that is the very, very low level. As I said, I think sometimes lack of skills at higher levels, they tend to cause more damage than at the lower levels. So entangling features, for example. So that's a design issue. It is an understanding of the domain, right? So knowing how to separate the concerns. So having training or a ways of learning a ways of understanding more the domain is also, for me, part of that, of managing the risks of technical debt.
I think there's on top of that, yes, but there's an organizational aspect. So technical debt for me can also be generated by how you structure the organization, and how difficult is it for people to get their job done. Yeah, because a lot of the times, if I have a blocker, we're lazy as humans in general. We're lazy. If I have a blocker, I will try to find a way to circumvent that. Like probably the right way of doing it is going through all of this filters and maybe bureaucracy, or asking for someone else to be involved in this, but that's not going to get me the results I want in the time that I want. So maybe I'll try to build my own thing, or I'll try to wait until the last minute, or I'll try to, and this is very often the case, especially in big organizations that want to like have a centralized. We already had an episode on architecture, and we talked about this designing by committee and all these things, and those things create, they're trying to solve a problem, they're trying to get that consistency and that, but they also introduce others, right? And people tend to find their way to solve the context, without looking at the whole, right? Because they're trying to get something done, And
I often call that cottage industry. Like you get a castle, and then you suddenly start, like lots of little cottages start building around the castle, and they are not protected by the castle, but they need to be there because there's no room in the castle itself. And I've seen many like legacy applications where you get this one large monolith, and then really small applications sitting all the way around it that are kind of doing just adapting what's in there. But actually what they're doing is, again, it's the same thing, that if statement that exists in there, and there. There's no different in this case as well. It's like they've just moved this if statement all the way out here. So something that changes and scuppers this one, the castle doesn't know what else is depending on it, right?
So basically, like we are quite often when we talk about technical debt, we talk about the side effect. We talk about the code is not great, or the coverage is not, test coverage is not to a certain level. But we very rarely manage, even like when you talk about managing technical debt, is like understanding why are we getting that. And as you were saying, Jose and Mesh, like I've seen that multiple times. Like people try to find a way around. If something is too difficult to do, being testing the system, being putting more requirements or whatever.
Or more convenient, We've been to clients, that they had different cloud providers just because, in this team, this guy knew X, and that's, what we're going to be doing. And then the same with different frameworks. And, like it's just a matter also of convenience in certain areas. No, there is like, oh, this is what we know. Let's do this. Or, oh, this is too complicated. I don't have the time to learn it, no, or to use it properly. I'm going to build my own thing that, because I only need this part, no, and they end up replicating, a product that maybe it's been around for ages, no. So yeah, we have lots of examples.
And then of course there is the common thing that we normally mention is like when you have a lot of pressure to deliver as well. So you say, hey, you need to deliver this feature by tomorrow, or so you just dump a new requirement into the team, and they need to react very fast. And you not only dump the requirements, but also the deadlines and everything else. And then of course that if then you are prioritizing the completion of the feature by a certain date and not the quality that you're going to build that feature. That is the prioritization that the business is doing. And there's nothing wrong with that, because this is another thing that we need to make sure that we can talk about, is that there's nothing wrong in incurring technical debt as long as we incur technical debt consciously and for a higher purpose. And I think that even in the previous episode we were talking about quality, that even this way of talking about technical debt or this trade-off is not that we are not focusing on quality. We are just focusing on different type of quality, right? So delivering a feature to a set of users or whatever, you might be prioritizing one type of quality over the technical quality, but you are doing that consciously. I think in terms of incurring technical debt, you can manage that consciously. But if this is the default modes default way of working, then that interest will come high. You need to pay, and it will come high.
But the problem here is that more often than not, we don't even know how much interest we are paying, because we think that is the norm, because there's nothing to compare against, right? So often, developers and so on, and everyone's complaining, the work change is not easy, it's not predictable, it's all the problems are there, but we don't know compared, like, if we made this thing better, how much better would that have been? A lot of the times when you have something that has incurred a lot of technical debt, it's very difficult to see an alternative. It's very difficult to actually understand what is the cost of all this technical debt. And because there is no comparison to say, well, if this technical debt did not exist, what would we have? And often, I mean, I don't know how you would measure that, but kind of keeping some kind of a measure of this cost of the technical debt is absolutely essential in then being able to see, well, okay, where do we invest? If, okay, we're going to try to, remediate some of this debt, where do we invest so that we get the best return afterwards? And I think that's a very difficult question to answer in a lot of cases.
And one related to that, one more thing is that because you talk about if we didn't have this technical debt, what would we have? No, and what I see is a lot of people are kind of able to see that end picture, yeah, but they are so far away from that they don't see what the steps in between are, right? And this is where things start breaking down, because in order to pay that, we then start a new system from scratch, no? Or we then start rebuilding things that are already working, and that is not viable, from the point of view of an investment. When am I going to realize this investment? No, I'm putting money, time, no, into this thing. When am I going to get it? No, when you're trying to rebuild something that is already working, right? Like, better or worse, it's already working. Yeah, that has been evolving probably throughout years, where the spec of what you need to build is the system. Like, there's no, you're trying to replicate something that is changing as you go, because business as usual needs to continue happening. So when I hear people, no, we're going to rewrite this from scratch, oh, we're going to, it's normally, I have a okay, maybe that's not the best option, but it requires a set of skills to be able to see what the intermediate points are, right? Like if I'm investing, how much of this can how much can this get me, right? Like, where can I get to doing this, and then what's the next step, and then what's the next step, right? Instead of just going full in and saying, oh no, this is not cool, we need to rewrite the platform in a new technology that we haven't tried either,
Well,
or stuff like that. So
but you're talking about those next steps, but each one of those steps would need to show some return on value, because otherwise someone is going to shut you down, right? If you keep going doing those steps without any value being brought back, it's not sustainable. So it's not just about finding the steps to getting where you need to be, but actually creating those steps in a way that each one is providing incremental value back to yourself, is reducing that debt, right?
Yeah, but there is a way to manage that, because the problem with technical debt is difficult to measure. There are different types of debt.
Mm-hmm.
They are difficult to measure because most of them are also subjective, right? So you can say, like, I think we touched upon that on the last episode where we talked about quality, the high level quality metrics, the low level quality metrics and stuff. But there is a way you can feel when something is not going well as well. So there is, I know that there is the metric side that is we try to make it a bit more precise, which is not easy depending on what you're trying to measure. But there is a gut instinct, a feeling that, like, you are in a team and you can have the feeling that you are always making good progress and everyone is happy, and every demo, the developers, the everyone involved, the QAs, the BAs, the stakeholders, the product owners, everyone is pumped up and say, hey, yeah, great. Okay, what you're going to be doing next? And we are working in that rhythm that every, if you're using Scrum and stuff, every sprint you are delivering stuff. So you have that good feeling. But we have the opposite feeling as well, where everyone is unhappy. Right, so the developers are unhappy because of the code or whatever, the pressure, the business feel that they don't deliver anything, and the QA is a pain to be a QA in that team because there's always something wrong, you have too much work. So sometimes, because it becomes so subjective, we don't manage that well. There are people pushing, okay, let's rewrite the entire system, which is not a good way of managing that or tackling the problem. But more often than not, it's completely ignored. It's almost like, for example, some people have either they don't even have a separate backlog, or they have a separate backlog. And one way of measuring is like, this is work to be done. So should we, let me see what you guys think. So how can we structure? So if you're talking about technical debt, how do we structure in a way, or what are the different ways that we can structure that so that we can not stop the business, as you said, but still tackle them?
I think you can try to address it at different levels. At a very basic level, I think there is a thing about taking the example of like weeds, right? As you're looking at your system and you come to make a change, and you see that there are certain things that are not great, and you refactor, but that refactoring is part of the work, right? So there should be enough skill within the team that this kind of work is happening constantly, that they are looking after the garden, as it were. They're trying to make those refactoring, making that change easy at the minor levels to kind of make it a bit better for the next bit of feature to come in. So this I think there is a lot in this, because actually if everyone does this, things will be more sustainable. But that doesn't mean that you'll never get to a point, as you said, you will be consciously making other decisions, bigger decisions, that are bringing in larger bits of technical debt, right? And so how do you manage these things, right? And I think here, like we were talking about quality metrics and those kind of things, these we need to be using them almost as our guide to say, well, actually, we talked about the value stream and all those kind of things, right? Change is becoming more and more difficult, because our metrics, the things that we are measuring, they're telling us that this area is a real problem, it's a real bottleneck. Yeah. And kind of using those metrics to say, okay, well, you are then taking that as a technical debt item that comes back into the backlog. So they should be all in one backlog and not separate backlogs, as you talked about, which as a dysfunction. And actually going back to the product owner or the rest of the team, however you prioritize your features, to say, okay, well, this thing needs to come in next, because here is a bottleneck measured by this. This is how we're measuring it, and actually making this change is going to move the needle on this, so that it makes our value stream better. And those are great discussions to have. And then that whole thing about, I want to change this, but my business is not letting me change it, can be minimized, because you are basing these um, requests or backlog items on pure value. So I think this is the only way to really start managing this thing, is that you start adding value based on certain measures, and you start looking at those features coming in as any other feature to actually pay back on that technical debt.
Mm-hmm.
Yeah, that's also my preferred way, as in, you're trying to deliver a feature, so you're trying already to, let's say, the change is driven by the delivery of value, right? We're doing this not because it's cool to refactor and look how nice my code looks and how clean. No, it's because I'm trying to get something done, and what I have right now doesn't allow me to do that, no, in an effective way, or in a time um, sensitive way, no. So that's for me, that should be the driver. Now you need a set of skills in order to be able to do that, right? Because you don't want to have the eternal refactor going on, no, and not deliver any features. And this is something that will quickly, in the beginning, nobody's against. Oh, you're improving that's great. They're against you not delivering, right? And then the justification being, oh, but we were refactoring this thing, and then we started pulling on the thread, and then everything unraveled, and now we don't know what to do, right? Because it sounds funny, but it's what happens
Very
to a lot of
familiar.
people if they don't if this is the first time that they're approaching something like this, right? So you need to know, up to where are you going to do that in business. You can always go farther, no, but maybe that's for the next story. Maybe that's for the next delivery of value that requires that extra investment, no. And before you were talking about doing it at different levels. No, this would be more like the work or product level. When you're looking at the smaller thing, like there's in particular two things come to mind, like the Boy Scout rule, like leave things better than you found them. This is something that is quite easy to do, so you're paying it constantly, as in, you got there, maybe you change the name of a variable, and now it's easier to read this thing, right? Maybe you did a bit more because you needed to get a bit more done, and then it's better. And then the other thing is like the rule of three, no. First time you do it, second time maybe you do that duplication, and then by the third time there's a pattern there. You can already start to see, maybe I should do something about it, no, and go back and touch it before it becomes 16 cases or 16 ifs that you now need to deal with. No, it just, the second one and third should be more or less where you have your threshold, no. And I feel that's important as well. Now, these things are not super that you have certain rules of thumb that you can use in order to start moving in that direction. No, but it needs certain self-control. No, and it needs, you being able to smell that something's not right as well. No.
Yeah, because there is the managing of technical debt in terms of we need to repay the debt or start, paying off that debt, and there is the management of not go crazy paying debt to the point that there's no reason for you. No, you don't need to pay anymore. Like, it's fine, you paid enough, right? So, and you end up creating more problems because then you might accumulate debt on the business side, right? That you're accumulating like now business work that should be going out. So, but as you guys were saying, like I was like thinking about many different things in different levels of technical debt and different ways of managing them all. So, for example, Mash was talking about, and you mentioned as well, Jose, the Boy Scout rule, right? Mash was talking about everyone doing their job and make sure that the areas that they are touching, they make it better. And so in there, managing that, for me, you manage in the small, and you manage at the developer level. So, when you talk about a vision for, we normally talk about, when you talk about vision, we talk about strategy and company and architecture. For me, there is a vision at all levels. So there is a vision for the feature that you are building, right? For the user story that you're building, there is a vision for that user story. There is a vision for that piece of code, right? So in that way, so when you are taking a user story, because you need to analyze that user story, right? Most people will try to at least give a good indication of size for that user story, what are the acceptance criteria, and the work involved to get that user story done. So for me, this is part of managing the work for that user story and all the local changes, all the local improvements that you do as you go along that user story, including defining the boundaries of those improvements, is part of the management of that user story. Is say, this is the scope of the user story, including my tests, my refactorings, and everything. Even if I said, like, in order to do this story, as part of the user story, I'll do some minor refactorings and then bring the change in, as we discussed before. This is one at the small, and this is for me managed individually or by pairs or at the very, very low level, team level, right? So there's not authorization and you keep asking for people anything. But then there are the vision for a feature. Let's say there is an epic so there is a bunch of user stories that will be bundled into a full-blown epic that will take maybe a few sprints, that the team will need to work together. They will be releasing the different stories, but they need the whole thing. In that one, maybe the system might not be prepared for that. So you might need to do something a little bit more specific. And they say, hey, before we even start this epic in here, is our system prepared for this epic? So there might be some architectural change that we might need to do, because this will be painful if you just try to shoehorn this thing in. And then as part of the analysis of the epic as a whole, you create the vision for the epic and all the technical side, not only the business side, and bring into the backlog formally all the technical work that needs to be done to bring the feature. There is also a different level of technical debt with a different type of management. There is one that is just, there is a bunch of shit in there that you always need to deal with that makes you slow regardless of what you do. A good example that we have in one of our projects. The test environment, the QA environment shared across, not only across the teams, but it's also shared with their clients when we need to do integration. So this is always a bottleneck for us to try out new features and stuff. So, or even like the test suite is too slow to run. So every time you try to add the features, it takes a long time. So this is technical that you pay every single day for everything you do. So then you need to make a decision. How I'm going to tackle that? Would I tackle that in more strategic? Depending on what you are doing, you can try to analyze it. Okay, what is the action? How, if we could dedicate some formal time, how long are we talking about? Are we talking about a few days, a few weeks, a couple of sprints? And maybe sometimes it's worth saying, you know what, we are going to stop the business. And we're going to stop that for one sprint. Or for a week, or to be a pair, or a team, and say, and we are going to sort this shit out. So that we stop paying installments every single day this thing. But this is a way to manage that, and you can express the business value and stuff. There are those low-level things that is always bothering you. The code is clunky and stuff. Let's say you have a team in a functional area, like the payments, the catalog, or whatever area of the business that they're working on. There are loads of minor things in here and there. They don't stop you all the time, but they are there bothering you. So some teams have those 20% improvements. So they say, you know what, for the next few sprints, let's assign 20% improvements, and then we can prioritize. This is a different way of managing technical debt, normally for local changes and stuff. And then you have architectural debt. And those ones, sometimes you say, you know what, we're going to put a full team dedicated to pay off the technical debt or to do some investigations, to create a new architectural way of working. But we are going to have a team dedicated to that. So I'm just trying to give different examples of different types of technical debt and different ways to manage those technical debts. Some of them will be far more informal, managed by senior people in the organization. Others will be less formal and managed at a much lower level. I don't know if it makes sense or not. But
yeah.
It's I think in a lot of cases, the way I see it, yeah, I mean, all these things, if the team itself is making the improvements or paying off that debt, as you said, there are very different levels that they can make it. When you have another team actually helping with that, then it's more when it's related to skills and capacity. But at all times, if you are even within the team, if you then decide that you're going to make this whole large scale change, you need to be very careful about two things. One is that do you have the skills to be able to do it? Because as Jose said, there are many times that you basically pull at that string and it unravels and you get to a point where you don't know what you're doing. And then suddenly, you've spent a month and you don't have anything to show for it. And that the other thing is very much related to that is how you measure the improvements, that investment that you made. Now, how do you measure it? If you have another team doing it because you don't have the skills. So for example, in cases where there's been a team that has a level of skill that has created that technical debt and they just don't know how to get themselves out of it, right? There you can have team, and we've done it ourselves where we've provided a team to clients where we are then kind of pioneering the ways to improvements, but at the same time making sure that people are being upskilled so that they understand this way of working, this way of designing software, this way of architecture, design, everything else, and they can carry it forward. Because that's the important thing. One is addressing the actual symptom, making it better, but the other is always addressing the root cause. If you manage to get yourself into a place where you are now having to stop the business to make your software better, there are a bunch of skills, practices, and so on that got you there. And you need to take a very hard look at that to make sure that you don't get back to that again.
Yeah, the last thing you want is some people on one side, they're cleaning the place up, and then the other one are making a mess on the other
exactly.
side. It's like it doesn't end ever. Like that way, you're not. You need to make sure that you are repaying it, and if it is being created, it's not being created again by the same reasons, or the same root cause. Yeah. And another thing that I would say, and you kind of touched on it, is the shifting the burden kind of pattern, right? Where you have a team that will be the one fixing things. No, just like you have a maintenance team, and then you have another team that builds. This team builds things, and this one is the one that maintains it, right?
Yeah. Or fixes the defects. Fixes
exactly.
the defects.
Exactly. And that's another. That's another. I would say anti-pattern that you need to be very careful, because what is happening there is you're not addressing the root cause, right? Before you said, the skills, but there's no way that these people can actually learn from what they're doing if they don't have to maintain it. Like this, if every project that I go to is a greenfield project, right? I can always, it's like, oh, it's perfect. I don't have to deal with the consequences of what I've done, of the bad decisions, and to some extent, a lot of people do that. They either start building systems and they move to a different company. They don't close the loop, on that learning. And I feel like that's important. That's why things like communities of practice, or like mob programming and so on, are quite interesting, because it helps share that learning and that knowledge that you have, and also trying to balance out how much of the work that people are doing is maintenance or having to deal with the poor decisions of others versus just greenfield every time.
And you mentioned like another aspect that we haven't explicitly touched upon, like communities of practice or stuff, but like deliberately create space where people can learn and share, right? And this is another way of managing technical debt, because one thing that we all need to understand, like a technical problem is a business problem. There's no such a thing as a technical problem is just a technical problem. No, the technical problems will impact the business directly. And if that is the case, addressing it, as you guys were saying, like in a more strategic manner, looking at the different types of root causes for the different types of technical debt that you have. Manage that as you manage all the business features. So you are in a long-term, well, most people will be in a long-term project. They will rely on that software, and the same attention and strategy that they put on the business side, they need to look after that software, and that needs to be part of their strategy as well moving forward.
You just mentioned one thing that we haven't explicitly said, which is most of the time we're thinking about long-running projects. You're building a product that is going to be there, it needs to last, and so on. When you are dealing with smaller projects, or with a project that maybe is coming to an end, I would probably follow a different strategy. You do need that learning, and you do need to do things better, but better is better next time, right? Like the next 3-month thing, of course you can always go back and fix and like apply that learning over, but it's, even if your projects are small, you still need to be able to learn from that, and you still need to understand how your past decisions created or made that job difficult for you, and try to apply forward as well, right? So that's another aspect, because there is, most big companies, they have like products that go for a very long time, but they also have smaller strategic things that need to get done, and then they still, like you have a system that's basically the control, the back office that your whole sales force is using, and it was built by 3 people just came out of a university who were here doing practices or whatever, right? That's pretty core. It is not what the user is seeing, it is not, but it has an impact, and how hard that is to change, that's also important, for the business. So
Cool. So I'm conscious of time. Anyone has any final say, any final words, and anything you'd like to share before we wrap up?
Well, I think as a summary, technical debt is inevitable, and you need to be very conscious about it and manage it at all the different levels, right?
Yeah, strategically, right?
Yeah.
So be part of the way you manage the project as a whole.
Yeah.
Now,
Jose?
I would add that it doesn't necessarily need to be a bad thing if you're using it strategically, right?
Yeah.
So
that you're making decisions consciously.
Exactly.
Right? The right trade-offs. Cool, awesome. So, and as always, if you like this episode, if you've been following us in our Fireside chat, if you'd like us to address anything, let us know, leave a comment, put your thumbs up. And I see you next time.
Thank you.
All right.
Bye-bye.
Bye-bye.
All right.